Welcome to the Old Iron Lever channel. My name is Bob, and this is the second video in a series on some spindle work on the South Bend lathe. Sadly to report, a disaster befell the lathe in between the two videos here. After I got it disassembled, I had the spindle all ready to go back in. I had inspected everything and put it back inside the cone pulley and got it ready to go. Went over to the lathe on the other end of the room to clean the seat where the bearing goes and all that, make sure it's all ready. And I hear a tremendous crash. And I said to myself, I don't even need to look to see what happened. It rolled off the bench and landed on the concrete and actually damaged the spindle. The threaded nose hit first, and it's had one thread knocked in it, caved in. That I could fix. I put it on in my lathe and took a dial indicator and measured, mapped the straightness of the spindle from one end to the other, and it wasn't pretty. The big end where the chuck goes, the bearings were fairly straight, or the shaft was fairly straight where it would sit in the bearings. It probably, the way it laid in the headstock, it showed 0 on the outside or the front end of the spindle, right where the bearing is, and on the inside of the front bearing it showed about a 0.5 run out there. So there's probably not bent on that end, but it was bent far enough down that it tipped it up slightly. On the other end we had 0 on the outboard end of the tail, the end where the gears are, what they call the back end of the bearing, of the shaft. And it, on the inboard side of that bearing, it read 1.3 thousandths. That's more than the tolerance you're allowed for the total clearance. And on the outside, on the very end of the spindle where the collet closer would go, it was 6 thousandths out. So it got whacked pretty good somewhere in the middle there. An ordinary shaft, you could probably straighten it and get away with it, because but this, I don't think there's any straightening it. So that's the bad. The good is that I called around and tried to find one. I found a guy named Ted, who goes by the Lathe Man, who I understand was one of the last tool room machinists at the South Bend factory when they closed down. And he has acquired a significant stock of South Bend parts. So I got a hold of him and asked if he by any chance either had a spindle or told me where I might look to get a hold of one. He said, yeah, he did. He had a new old, not a new old stock one, a used one that was in good shape, a little bit of surface rust, but it was reasonable. And I said, well, I really need it. And he said he would go out in the storage area and find it, and before he gave me any final quotes on anything. And so the next day he emailed me and said, yeah, I got it, but I also found a brand new old stock camlock spindle, and if I would like that, it's a little bit more money, but he had it available. And I said, well, yeah, there's the good news. I was able to get this camlock spindle, brand new, and upgrade from a threaded spindle to a camlock. Now that's going to require me to build new backing plates and all that kind of stuff. And we'll see, we won't see the backing plates, that'll be a subject of another video, but we will get the spindle fitted and shimmed properly and all the adjustments made, and get at the time I did this, I couldn't find any of the little pins and springs that lock the camlock cams into the spindle. So I made them, and there's a segment on making a part for your lathe where you need a lathe, but you don't have one until you get your lathe fixed. And what I did is I turned them on my milling machine. And if you had never done this before, it was kind of interesting to see. So we'll go on into the video and see the reassembly and adjustments and all that, and building the pins to lock the cams in place and all that, up to the point of having the spindle ready to receive a chuck. And we'll go from there. I've got the spindle just sitting in place now. I put the full shim pack on both ends, and I've tightened down the main bolts for the bearing caps, and then I've put in the little extractor screws and tightened them up. So it's as it should be in a running condition, and you'll see it's actually real free. So the procedure for measuring spindle run out, or the shim pack on a south bend: press down. I put a stick through the thing, press down, get the stout press, zero your dial, and then pull up with a good stout press, and we got about a little over 8 thousandths. We need to be between 7/10 and like 1.3 or 4, something like that. I'll look it up, but that's the way we measure it. So this one's got to lose about 8 thousandths in the shim, so maybe 7 thousandths, something like that. So we're 0 and yeah, we're 8. I'd lose 7. Okay, now we'll go over to the small end. There we go. Okay, now we're down. Zero. We're about 15 thousandths or so. So we probably need to take at least 14 out. So 7 on one end and 14 on this end, huh? So the process for taking this apart, and I probably covered it earlier in another video, but is to take these expander screws out first. That is important to do that first, because if you loosen the cap up with the expander screws tight, you will tear up the edge of your bearing. I'll show you that in a second here. And you put a rod down inside the bolt hole, pop it a little bit, pop it a little bit, lift it off. Okay, we'll rinse and repeat on the other end. Take the expander screws out. And the book on this says that both the expander screws and the main bearing cap screws are moderately tight. So I don't know how many foot-pounds that is, but it's certainly not the same for the little screws and the big screws. But anyhow, I'm going to move in a little bit, show you those expander bearing expanders a little closer. That's these things right here, and there's a little dovetail on the inside of the bearing, and there's a little dovetail on the bottom of this. And as you pull up on it, it expands the bearing, so it runs up tight against the bore formed by the casting and the cap. So it's an essential process, but you can see that the way this thing is made is it pulls it up against this piece inside of here. If you tighten those screws up, you're gonna, you're pulling that expander up tight. If it's in that position and then you undo these caps and start loosening it up, you're gonna be pulling this whole thing right up. You're gonna force it up between the two dovetails on the bearing. And I've seen pictures of damage on it, and I don't want to be one of the poster children for that. So anyway, I'm going to take the shims apart here. This is a laminated shim. I actually bought a brand new set of shims for it. So I'm going to mic this and take a total of 15 thousandths off of, or 7 thousandths off of both sides. That should bring me in close. And then I'll put it together. We'll measure it real good. If we get down where we need to take half a shim thickness, you take one off one side and not the other. And then if you have to take a little more off, then you take one off the other side, off the second side. So you can get it pretty close, and like I say, the spec is 7/10 thousandths as a minimum, and I think it's 1.5 or 1.3 thousandths as a maximum. So this one on the previous spindle ran real tight. It ran between 7/10 and a thousandths. So be back after I've gotten the shims dialed in a little more. Side here. Okay, pull up on it. About 1.3, 1.2, something like that. I think we're going to be right where we want to be. Now, put the dial indicator away. We're going to go ahead and tighten up the thrust bearing. And it says tighten it up hand tight, which that's what that is, and it's actually tight enough I can feel a little bit of difference here. Okay, see, tighten it up hand tight. and then back it off 3/8 of an inch. Tighten up the collar. Good and snug. Now the next thing I'm going to do is I'm going to put the belt on, and I'm just going to run it a little bit and see how it feels. You know, is it stiff? Is it taut? Anything like that? Okay, got it all the way up on the little end here, or the slow end. Actually, before I go too far with this, I got to get my lubrication system back together. So I don't know if you remember in the disassembly video, but we pinned the felts down. Now I've lubricated these things, so I just pulled the pin out so the spring has pushed the felts back up against the spindle. So we're set there. I'm going to go ahead and put the plugs in. Because really don't need to have these apart at all anyway. Okay, wrench in there and turn the oilers back up into position. I'll get this one the same way. Okay. I feel better about running it with lubrication, don't you? After I get it running for a little while here, I'll probably change speeds, go up and down, feel of the bearings, see if they're getting warm or anything. And then I will remeasure everything, see if anything's changed. So, put you back to sleep until I get something interesting. Well, as promised, I'm going to recheck the play on everything. I will tell you that this bearing on this end started getting a little warm, so I thought I would. It's definitely something I want to check. So, lean on it good. Dial it in to 0. Pull it up good. We've got about 2 thousandths, so that's probably plenty. And it also could be the thrust bearings, but they appear to be free. Yeah, I can move them a little bit. Might give them a little bit more loose. And let's go check the end over on by the chuck end. Push down on it. The official spec is 75 pounds of force. They didn't say how far out on the stick. What, 0.2? Okay. So that end is still fine. It's not warming up or anything else. I am tempted to pull a little bit of a shim out of the other end and bring it into spec. 2 thousandths is more than the spec, so Anyway, one thing I did forget to do on that end was loosen up the belt first. Okay, the last shim adjustment was actually a problem with installation. The shim, when I put it in place and put the bearing cap on, it must have shifted, and the pin, the alignment pin on the bearing cap, caught it and wedged it. So once I straightened that out, I left the shims exactly the way they were. And now we go down. We're looking at -1 maybe. Go up. We're at 9. So the range they want is between 7/10 and 1/1000. So I'm going to say that back is dialed in. Yeah, see, we're tight on here, I believe. Tap it a little bit. I think our thrust bearings are a little tight. Yeah, I can't move them, so I think we're significantly too tight. So we will get a screwdriver out here. Okay, now it's just, okay, we're going hand tight, and then they say come back off 3/8. And I'm going to double check my 3/8, but I believe that's about 1 tooth. Find a ruler I can actually read. There we go. So 3/8 is about almost 2 teeth. So I'm going to take it from here to about there. Okay, we're free there. Not free there, but that doesn't matter. Okay, let's see what we got here. First, let's just see how it rolls. A little tight. Let's see what it looks like. Okay, I got the spindle for now. It's a little bit on the loose side. I'm going to run it a while, and then I'll come back and recheck it and possibly swap out a 3 shim for 2.5 shim, or 1.5 shim. 2.5 for 1.5. Anyway, that'll be coming up later. Okay, I'm going to put these little pipe plugs in here. And then the next thing we're going to do is put the back gears in and adjust them. Since I'm going to be playing with the back gears, I've got the cone pulley disconnected from the spindle. So first I'm just going to kind of put this in, generally in where it belongs. There's an eccentric on this end and an eccentric on this that this bushing will hold. Got to get a little oil on them and then slide this together. see how it runs like that. Okay, it's a little noisy. I think we're running a little too tight. So I'm going to back that eccentric up just a touch. What I've done is adjust the eccentric on this end, so when I'm all the way in, it doesn't have any excessive rattle. I mean, it has rattle, there's no doubt. There's no dimple on this one, so I'm going to drill a little dimple in it. When you put it in is an adjustment for the tension on the handle. If you don't get enough tension on it, it tends to walk back out of gear when you're putting it under a load. So. Okay, now get tighter than that. Still engages, but it's got some drag on it, so that's what we want. And while we got it here, let's lubricate it. And we'll lubricate the spindle too while we're at it. Put the covers on and we'll be done with that part. Okay, we got the spindle mounted on it. We've got the bearings pretty well set. And at the time I started ordering parts, it looked like South Bend did not, or Grizzly, did not have the internal parts for the deal that holds the, this is the cam, and there's a pin that drops down in between the slots here in the cam. And I don't know if you can see it real well, but there's a little dimple right there. That's a little detent, so that when you turn it to the open position, it kind of clicks into place there. So there's three components that go down inside this. The topmost component is a screw. It goes in here, so a 3/4 inch long 5/16 screw. Then there's a spring, and then there's a little pin assembly that has a rounded end on it that sits in that detent. And I need to measure all these things to figure out exactly what it is I'm dealing with. I did measure the width of the cam groove. Now the width of the cam groove here is at 140 thousandths. So I'll go, just a thousandth or two under that. I've got the screw is a 3/4 inch screw, so we know that dimension. Now I need to get the overall dimension and then the height of the groove, so I can, it actually goes smaller. This width right here is smaller than the width of the hole, so I have something that's just shy of a 1/4 inch coming down in here, and then it'll neck down to 130 to drop into here. So I'll need to get that hole, the depth of the narrow part, the depth of the wide part, and leave enough room for a spring to go in there. So I got some 1/4 inch rod here, and it doesn't go down in the hole. I'm going to have to turn it down just a little bit. I'm going to take another measurement of it and just kind of loosen it up a little bit. I'm thinking a couple thousandths will get it where it drops right in there. I have a lathe that's not able to go in service yet because the cam locks aren't ready, and I need to make parts for the lathe. So what do? We put it in the mill. Nice thing about the mill is I have a DRO to work with, so not worry too much about the Z-axis. We're just going to take a little shave off of this thing, a couple thousandths off of this. So we're just going to touch off and just skin the whole thing as far as we can reach up in there. Got it running backwards so it turns into the cutter. Okay, we're touched off. And I'm going to just leave it touched off plus, I don't know, a thousandth or so. Okay, I'll go back to forward speed here. Turn it up. Yeah, that fits real good. So we need to make the bottom of these pins a little under 140 thousandths diameter, and call it 120, call it 150 long. That'll be a little bit too long, but that's okay. So 150 deep and 140 wide. So we're going to go up and touch off the bottom of this thing and face off the bottom. Reverse it. Here we go. going to face off the bottom here. Okay, now that's going to be our Z0, and we're going to go in about 100 thousandths or 50 on a side, and that should leave us a little oversized. So our Y is still zeroed to the original diameter. There's 70. There's 100. 10, 20, 30, 40. It's 150. Now we need to round the bottom off and just give us just enough to catch that, that dimple. I'm just going to do that with a file. Okay, there's the dimple. So we're turning. We're just catching that dimple. I want to give it just a little more chamfer on it. I think that's going to do it. Okay, I've got them cut off bandsaw. Got the first one chucked up in there, and I can barely see the mark up in there, but that's all I need to do. Well, let's see how they work. Slide one of the cams in. Okay, I'm sure I'll have to tickle them into place here. Okay, it's all the way in. Put a spring down in the hole. Put a cap screw in the hole. let's see if we can lock and unlock it. That's it. Now we're ready to make a faceplate up for a chuck. Well, thanks for watching. I hope you enjoyed that. There's some things you don't see every day in that video. And the next job for this will be to put some backing plates. I got some blank backing plates. Get them locked into the cam lock and turn them to fit the chucks. And like I say, I'll do another video on that, just not part of this series directly. And if you liked what you saw, well, give me a thumbs up, or even subscribe. That's always welcome. And if you have any comments you think I'd like to hear, we'll surely add those too. Until we get to the next video, happy trails.